Multi-camera networks are growing ubiquitous for a large range of applications. As the number of cameras in the network grows, there are important challenges to be considered in terms of how to best acquire images and process them. At its core, a camera works by sampling a scene using an array of pixels. However, when we sense a scene at high spatial, temporal, and spectral resolutions, the camera has to deal with a large amount of data. This data deluge is typically handled using compression algorithms that reduce the dimensionality of the data without significant loss of information. Reducing the size of the data helps keep transmission costs low. However, this paradigm of sense and then compress is inherently wasteful. An emerging paradigm for sensing seeks to alleviate some of these challenges by merging compression and sensing in one holistic step. This idea is called compressive sensing. What makes compressive sensing possible is that images, videos, and other real-world signals have redundant structures. For example, gradient magnitudes of natural images are known to follow certain statistical distributions. This structure can be captured using a wavelet representation where most of the signal is sparse or takes values close to zero. Compressive sensing enables a novel class of imaging architectures and algorithms to recover signals from far fewer measurements than sampling with a traditional camera. Videos, which are inherently more redundant than images, can often be sensed at much higher compression ratios. Compressive sensing provides many important benefits for multi-camera networks. First, when we have cameras with overlapping views, the data rate can be further reduced by exploiting multi-view constraints. Second, we can enable inference tasks such as tracking and 3D reconstruction directly from compressive data. Shown here are 3 views of a 3D point cloud directly recovered from compressive cameras. Finally, just as redundancy can be exploited across multiple views, when using multimodal cameras, we can exploit cross-modal redundancies to achieve higher compression ratios during sensing. In summary, compressive sensing alleviates some of the important challenges towards the scalability of camera networks by sensing only the relevant information.